what Oliver's done for us up here is he stepped us through getting the third side using the Pythagorean theorem, right? A squared plus B squared equals C squared. I hate that formula. I know a lot of you guys memorize it, and as soon as you see a picture or something, you start labeling any size A, B, C, and assuming that that's correct or that's. Just take the two shorter sides, square them, should equal to the square of the third side, right? And then you do the square root. So what Oliver's done here, 118 squared is 324 plus 100, 424 square root. So again, radicals. That's why we taught you radicals and simplifying radicals. That's the exact value. We always want to see exact values. So you don't even really need your calculator to figure out the square root of 424 because you just leave it. Okay, that's the exact value. The additional step of actually simplifying it, you saw that 4 divides into this 106 times, so it's really 2 square root of 106, right? We want to simplify our radicals, leave our answers in exact form. I'm not going to be there in the final exam, walking around, making sure that you don't put a decimal here. You need to start learning this on your own. The instructions right at the top. Leave all your answers in fractions, reduced fractions, and radicals in simplest form. In there, I even bolded it for this test, and apparently that wasn't enough.
Does it matter to you if do we need to we lose marks if we don't round the angles? Like say if we had 60.95.
I'm a little bit more lenient on that because sometimes we may not be explicit on rounding, right? So for example, once we get to here, we talk about the tangent, right? If we didn't say to the nearest degree and you do 2 decimals, I'll be lenient on that. Okay? So here, Oliver took the tangent of theta, so this is theta over here, this angle, which is opposite over adjacent, so it's 10 over 18. So tan of theta is, so what I'm going to do is I'm going to correct this form here a little bit. Is that this part is not mathematically correct, technically. Okay? So what he has here is tan of theta is equal to 10 over 18. So you want to take the inverse tan of both sides. Okay? So that just leaves us a theta on this side. Okay? And I saw a lot of this on the test. I didn't dock people marks for this. But I will make sure that you're clear on how you write the inverse of tan. It's not the number and then inverse of tan. You do the inverse of tan first, and then in brackets, the actual value you do the inverse of tan of. Okay? So make sure you got that format correct. Yes, Jimmy?
Do you need us to put that step in? Can we just go from, can we just go to tan and then we have to write inverse of tan?
How long does it take you to write that, Jeannie?
No, it's okay.
How long?
I don't know, but I'll write it.
Thank you. And then we get theta is equal to 29 degrees. I want to see the degree symbol there, okay, because we're talking about degrees. Okay. So and then finally figure out this last angle. He did 180 minus 29 minus 90 gives us 61. While this is correct, again, if you want to be a perfectionist, you want to make sure you did the best job that you can, I wouldn't necessarily figure out alpha that way. Okay? If you got theta wrong, for whatever reason, and then you use that calculation to calculate alpha, I'm less lenient. Okay? What you should do, hopefully, is you just do the tan of alpha is 10 over 18, or 18 over 10. Okay, so you just do the tangent of the other side. And then here you get alpha is the inverse, tan inverse of 18 over 10. And hopefully there you get alpha is 61 degrees. That's how you sort of, at the same step, confirm that you got the right answer, that you got 29 is correct as well. Okay. Again, how long did that take me to do? 30 seconds. double how long it takes you guys to do it, extra minute just to double check your work. Okay? In fact, as you get more proficient at it, you'll get faster at it, which is what homework is all about. Practice being proficient. Yes, Daniel.
I know that 90 came from the right angle, but 180 goes in straight.
180 because there's 180 degrees in a triangle. Okay? Nothing to do with straight line, although I think it might have derived from the straight line theorem. But basically, it's 180 degrees in a triangle. Okay? I want to take a couple seconds here to point this out. I can't give your tests back. I do have them all marked. Your marks are up on Blackboard. I can't give them back because there's some people that still need to write. So what I saw on the test was people doing a squared plus b squared equals c squared. What kind of a triangle do you need to do this on? Does that only apply to? Right angle triangle. So we're doing a similar triangles and people were still doing a squared plus. That's what I'm saying. You need to understand the formula. That only applies to a right angle triangle. Right? The tangent ratio. It's great that we know it. But what kind of triangles does that only apply to? Right angle triangles. Okay? Next unit, you could do this on non-right angle triangles. For right now, this only applies to right angle triangles. So unless your triangle is right angle, you can't do this. Very important. Okay? Any questions on this example? No? Okay, so today we're going to learn about this thing called SOHCAHTOA. Okay, when I first heard this word when I was in school, I thought it was like an Indian word. You know, like a native Indian word, so like Cree or something like that. I thought it was this great Cree or, you know, mathematician. What it is, it's just an abbreviation. We'll learn what the abbreviation is about. So take out your notes, write this down, SOHCAHTOA. This is a triangle that we started off with the tangent ratio with an understanding. Okay, so remember we had that triangle when I drew the grid. The grid was looking like this. Alright, it's supposed to intersect there. Still can't hit it. Still can't hit it. Anyways, it had the axes. We had this triangle, right, that we developed. So the bottom side is 9. The vertical side is 6. How do we calculate the third side again? Yeah, Pythagoras theorem, right? It's a right angle triangle. So it's 9 squared? 81. What's 6 squared? 36. So I know that this is just the square root of 81 plus 36, which is the square root of 117. Right? Do I convert that to a decimal? But this can be further reduced. It's really 9 times 13. So it's really square root of, 3 times the square root of 13. Okay? So that's the length of the hypotenuse. Oh, which brings me up to another point. On the test, it seems like we had problems recognizing which was the hypotenuse. Which side is the hypotenuse? Sorry? The longest. But you know what? Sometimes in a triangle, it's hard to tell which one is the longest side. What's the easiest way to pick off the hypotenuse on a triangle that's labeled like this? Rob?
Opposite of the right angle?
Yeah, we look for the right angle, and the hypotenuse is on the opposite side. Always. In fact, you will discover once you look at triangles, the triangle with the largest, where it has the largest angle, the opposite side has to be the longest side. Okay? Obviously, in a right angle triangle, no other angle can be larger than 90 degrees in this one. Okay, so that's how you figure out the hypotenuse, the side opposite. So here we have this length. Now let's do a little review. Tan of theta. What's tan of theta again?
Opposite over adjacent.
Sorry, opposite over adjacent?
Then sin would be hypotenuse over opposite.
This side of the board is driving me crazy. Adjacent. So I'm going to abbreviate this. It's just O over A. Okay? Opposite over adjacent. So in this case, what is it? Sorry? It's just 6 over 9? Same as 2/3. Okay? So that's talking about to this angle theta. So humor me, take out your calculators. Let's find out what theta is. So in order to find out what theta is, we need to take the tan inverse of 2 over 3. So tan inverse of 2 over 3 is
33.69.
33.69. Okay. Now that we've question mark?
How you got the 0 over 9, and how'd you get to 6 to 9?
No, it's not 0 over 9. It's O for opposite over A for adjacent. Okay? Good question. I know my handwriting's brutal. Okay? But that's how we just remember it. O over A, opposite over adjacent. So now that we know the length of our hypotenuse, we could do something else with theta. It's this thing called sine. Okay? So now we see that it's sin. We say it's sin. I won't consider it a sin. But it's really sine. Okay?
Why don't they spell it
Same reason why we don't say tangent with a G and T. We're lazy. So we just want to reduce it to 3 letters. So it's really sine, S-I-N-E. For some reason, somebody decided to abbreviate all the trigonometry functions to just 3 letters. I guess it was a lot of work to write that extra E.
Maybe it's better for calculator.
Could have been, I don't know. So sine of theta here is. Have a question here?
Yeah. You told me a second ago. I forgot. The second 10.
So you look above your calculator, because you don't have an actual calculator, it doesn't show you tan
No.
inverse.
No.
That's what they're asking.
Right? Tan. If you look at any other calculator above the tan button,
10.
tan -1. So that's what the second.
So I take a 2 over 3 and I do the 10 in.
Depending on your calculator, you're gonna do tan inverse first and then your number, or your number and then tan inverse. This is why you need to do your homework, so you can figure out how your calculator works and you get the right answer.
Yeah.
Every calculator can be different, and I can't go around to everyone saying this is how you use your calculator. You need to experiment on your own. Okay? So for sine of theta, what this ratio remember, that's what all these trigonometry functions are. They're just ratios comparing two sides. Okay? So for sine of theta, it's really we're comparing the opposite side to the hypotenuse. So here, we'll abbreviate with O. We'll keep O as opposite. We use H for hypotenuse. Okay? So in this case, what's that example? In this case, what's sine of theta?
6 over 3. Right, 3 square root.
So it's 6 over
3 square root.
3 root 13.
Yes.
So that's equal to 2 over root 13.
Oh, because you cross reduce.
So yeah, cross reduce. I divide both top and bottom by 3. Then I get 2 over root 13. So sine of theta is 2 over root 13. So what do you think the opposite function of sine is? No. Let's try. Inverse sine. Okay? So inverse sine is written like this. sine -1, the sine of theta. So here we get sine inverse 1 of 2 over root 13. You have a question, Katie?
Yeah, like, I know like sine is like opposite over hypotenuse, but where do you put the number? Like, is it somewhere on the triangle or?
Well, here we know that the opposite side was 6, and the hypotenuse was 3 root 13.
But like,
What do you
what
solve?
does that number like give you? Like,
It's a ratio.
but where do you put it? Like, why do you need
Theta.
Well, it's a ratio of this. Just like tangent was the ratio of 6 over 9.
the tangent you actually put up as like an angle? in the triangle?
Well, theta is still the angle.
Oh, it's a different way to find this. The
Theta-
circle with the line.
Theta, yeah, so it's called theta. Theta is just still an angle. So now we're saying that the relationship, the sine relationship of theta is opposite over hypotenuse.
So, is there only one sine, like theta? Like, why do you need multiple?
If you have different.
Just, okay, can you just bear with me?
Yeah.
Okay? So in your calculators,
Three equations and it has the same.
in your calculators, bear with me.
Good math.
In your calculators, do sine inverse of 2 over square root of 13. However it is that you need to do in your calculator. Same answer?
Mind blown.
So we got here, using sine,
Oh, it's the same thing.
we got 33.69 degrees. Okay?
Yes.
So cosine. We'll just work on how to do the calculator after this picture.
Oh, okay.
So cos of theta, last comparison that we can have is we can compare the adjacent side over the hypotenuse. What's that? Why does it become italics? So cos of theta, we could abbreviate this as A over H. Okay? So it's really adjacent.
So this is like.
Adjacent over hypotenuse.
This is the sun.
No, we're always talking. I've always been talking about theta still. We're still talking about this angle in all three instances. Okay, so we're comparing this angle to doing the ratios compared to this angle. Okay, so for cos of theta, what's the adjacent side? 9. And what's the hypotenuse? 2 over root 13. So cos of theta is 3.
Over 30.
Wait a minute, it's not over 2 root 13. It's over 3 root 13. So it's really 3 over square root of 13. Okay, so we take the opposite or the inverse function of cos is inverse cos, right? So here we get theta. So you go to cos inverse. I'm getting smaller here. Cos inverse of 3 root 13. So what answer do we get for that? So you take 3 divided by square root of 13, inverse cos of that. Now you're all looking at me, and I don't know if I heard it already. Why the frig would you give me 3 different ways to calculate the same thing?
Yeah. I was waiting. Okay, this one?
Are you guys answering me?
Yeah.
Why you would want 3 different ways to calculate the same thing? Sure, Marcus.
Because sometimes you're not given all the sides.
Yes. We give you 3 different ways, and I just want to demonstrate that all these trigonometry functions are related. Okay? So that you will get the same answer. Right? How often am I nice enough to you that I actually give you the length of all three sides?
Not very.
Never,
Why not?
because I'm a mean person. You can complex person with whatever.
Be a nice person.
No.
There's always room for improvement.
Because you know why? The real world is not nice to you. The real world never gives you all the answers.
Just be happy with this on this.
The reason why we need all the trigonometry functions is I could give you a question like this. Right?
That's it?
And I say that this is 36 degrees.
That's so mean.
That's it. Solve the triangle.
Yeah, the sides too.
I hate those problems.
And then I give you this side. No, that's not. Yeah, I give you this side, 9.
At least you can find all the
Yeah, you
angles.
can, you do the tan theta.
So the question is, what happens if I just ask you to find this side? Just that side.
You still have to solve that.
This one, the 6 you isolate for A and then you do the.
Well, isolate from A. What's A?
You would
And you should
do
get that. You
opposite.
do tan of 36 degrees equals 9
Oh,
over A.
Okay.
divided by
Okay.
A.
So let's go where Jenny's going with this.
No, in this.
So you say tan of 36.
No.
So you say tan of 36
No, I just do.
is opposite.
It's all the same.
So I'm gonna create another variable here, A
Alright, it's all for six.
over A.
Just right left.
So I'm gonna solve for A.
Yeah.
You go to university
Right.
and take a box and
Nothing wrong with that. If I've only taught you tangent, that's the only way you can do it,
So then Mr. Tan, then it
right? If I only taught you tangent, that's the only way you can do it. But now because I've taught you two other things, what side is this relative to 36? Opposite. And what are we looking for? Hypotenuse. So we're looking for a relationship between opposite and hypotenuse, which is sine. So theta is sine inverse. Well, actually, don't you know what theta is? So sine of 36 is opposite over hypotenuse. So hypotenuse is really 9 over sine of 36. Okay? So this would have been a lot easier to do. We know we're going to get the same answer. And that's what the previous slide was showing. We're going to get the same answer. But this is a lot easier to do than going off solving for A, and then either doing that using the Pythagorean theorem to get x, or however, right? You'll still get the same answer, right? Nothing wrong with that, but I was just trying to teach you being a little more efficient. Okay? So this is why you want to understand all three trigonometry functions. If I was to ask you, solve this triangle, in other words, I want all the other angles on other sides, then it's up to you. You may start with tangent, and then calculate the rest. You may start with sine, okay? It's up to you. The only thing you couldn't start off with was cos of 36, because you don't know this one and you don't know that. Because cos of 36 is adjacent over hypotenuse, you have two unknowns. You can't solve for that. That's all.
Since you're trying to find the hypotenuse, how did you get like sin 36?
Because this is my angle.
Oh, you just brought it to the
Can we
other
call
side.
it?
No, this is my angle. I'm looking at sine of 36. So sine is the relationship between the opposite side and the hypotenuse. So sine of 36 is 9 over 8. So you just start off with sine of my angle, beta, is opposite over hypotenuse. And just start plugging in what you know. So we know theta, or angle, is 36. And we know the opposite side is 9, but we don't know what h is. Okay? Yes, Katie?
Like originally you gave us just the angle, like 36, so from there you could find the other two angles. But then
What?
how would you find the other, like the outside length?
I could, if I didn't give you any lengths, you can't figure it out at all.
Okay, but you can find all the inside angles.
You can find all the inside angles, yes, because then you just do the 180. You don't even need.
specify that. Because obviously you can find the length.
Pardon?
Like, would you do that? Like, would you give it?
Would I be that mean? No.
Just give you the
I wouldn't give you something that was impossible to do because that's not even mean.
You give us full marks, we don't do it.
So back to SOHCAHTOA. What did this come from? So how you remember these trigonometry functions is, I'm going to do it on a clean sheet.
Do it again.
How is tangent opposite sine
So what I do is you take the first three letters, so, which is sine,
Are you serious?
is opposite over adjacent.
It's so helpful. Probably
That's
would not
so.
ever remember.
So that's how you remember. Sine is opposite over adjacent, so that's where so comes from. Ka
Can it be
is cos is adjacent over hypotenuse. Right? So that's where the ka comes from. Cos is adjacent over hypotenuse. And finally the toa is tangent is opposite over adjacent. Toa. Okay? So that's how you can remember the trigonometry functions, all three of them, and the relationship between the sides, the ratios. Okay? So that's where SOHCAHTOA comes from. So as long as you remember it,
But we stack.
yes. Okay? So that's where SOHCAHTOA comes from. Really, that's what trigonometry is. It's really just taking your angle and doing ratios of your two sides of a triangle. And doing lots of work with that, get familiar with it. Because it does get a lot deeper, and we'll see that in chapter 8. Okay? But this is sort of like the basics. So any questions regarding sine, cosine, or even tangent? So the key things that you need to know is, as long as you know 2 of 3 things, you can solve for the third thing. The hard part is which of the 2 things that you actually know, right? So they're actually going to be either 2 sides, that means you got to find an angle, or you're given an angle and a side, and you need to figure out another side. And that's where you got to figure out, well, which of the trigonometry functions I need to use to get that. Okay? Easiest thing to do, draw your picture of a triangle. We all drawing perfect triangles after this unit. Okay? Because that's where you're visually going to see which was my opposite side, label your angle, which was my opposite side now, which is my adjacent. And that's 2 parts that's confusing a lot of people. Which is the opposite side, which is adjacent. Hypotenuse always stays the same. Right? So draw your right angle, your square, to label your right angle triangle. The opposite side of that, or sort of opposite side to that angle, is your hypotenuse. So just go off and label that, and you'll be good. Okay? So this is the homework.